Hello viewers, I am Mrs. M. Govindammal, Assistant Professor of Computer Applications, SFR College for Women, Sivahasi. In this video, we are going to discuss about process control block. In short, we can call it as PCB. Every process represented in OS with the help of PCB. The process control block, every process has its own PCB. The process control block specifies the information about the process. Now let us see the diagram for process control block. The process state, process ID, program counter, CPU registers, memory information, process scheduling information, accounting information, and so on. These are all the various fields of process control block. Now let us see the process state. We have the several states like new state, ready state, running state, waiting state, exit state. These are all the various state of process. Now let us see the new state. Whenever the process is created, which is called a new state. Ready state. Ready means the process is ready for executing by the CPU, which is called ready state. Running means the process is currently executed by the CPU, which is called running state. Waiting means the process is waiting for some input-output operations, which is called waiting state. Finally, the exit means the process has completed all its operations, which is called halt or exit state. Now let us see the process member. Each process member has a unique identification number, so that ID is nothing but process member. So the process member is unique identification number, so that ID is nothing process member. So the process member is called as on ID. The unique identification number is given by the process. Now let us see program counter. The program counter always contains address of the next instruction to be executed. We have the process that contains 5 instructions like I1, I2, I3, I4, I5. Our process contains 5 instructions. Let us show that while executing I3 instruction, the process execution is stopped. Now, the help of the program counter, CPU will execute the next instructions. So, already I3 instruction is executed. So, what is the next instruction? I4 is the next instruction. Now the CPU searches the program counter now start I4 instruction. So what is the program counter? The program counter always maintains the address of the next instructions to be executed. In several occasions, the CPU stops the execution process. The CPU receives interrupt from the OS. So the CPU stops the execution of the process. So now which instruction CPU execute the next? It should be decided by the program counter. Now let us see the CPU register. The CPU registers are used to store enough data. Generally, the data is stored in form of register. CPU cannot perform the operations directly. We have some instruction like A plus B. A should be stored in a register. B should be stored in another register. Now CPU perform the operations on those registers. Here we have program counter, several registers like register, accumulator, base register, limit register, index register. Likewise, we have the several registers. Now let us see the CPU scheduling information. It maintains the scheduling information about process. We have priority scheduling algorithm. In the priority scheduling algorithm, CPU executes the process in priority wise. So the priority information will store here. Let's process P1 has priority 1, process P2 has priority 5. We have a round robin algorithm. In round robin, the process will execute especially for time quantum. Let us assume that time quantum is 5 milliseconds. The CPU executes the process only for 5 seconds. So that CPU executes several processes. So CPU scheduling information means it stores the scheduling information about the process. Now let us see the memory management information. The memory management information that manage the memory efficiently. Operating system maintains base register, limit register, page table, segmentation table, and so on. The base register means it contains starting address of the register. Limit register means it contains length of the register. So how many instructions that contains? These are all the memory management informations. Now let us see accounting information. The accounting information is stored information about CPU. So how much time the CPU executed the process, how does the CPU related statistics, let us CPU stored the process 15 milliseconds, CPU executed only 5 milliseconds. So how many milliseconds it has executed for 10 milliseconds. Now let us see the list of open files. The list of open files which are opened like sample.c, sample.c++, sample.java. These are all the list of open files. Now let us see the list of I/O devices. The list of I/O devices contains how many I/O devices are allocated to the process. Let us printer is allocated, let us scanner is allocated, let us keyboard is allocated, so that the list of I/O devices used by the process will be maintained in the I/O devices. Thank you viewers for watching my video. We will see on next video.